Okay, so the question's on page 317, starting with number 27, which says 3 loads connected in series to a battery have a resistance of 15, 24, and 36 ohms. If the current through the first load is 2.2 amps, calculate. So the first thing you do is draw it. Okay, so you need to draw these. This is not an option. Draw them. And it tells us this first one is 15 ohms. The second one is 24 ohms. And the third one is 36 ohms. And it says that I1, the current through the first load, so I1 is 2.2 amps. And it wants to know the potential difference across each load, the equivalent resistance, and the potential difference of the battery. So the first thing is to say, okay, in series, what's the same? And in series, it's the currents that are the same. So I total equals I1 equals I2 equals I3 equals 2.2 amps. And once we know that, then life gets easy because it says the potential difference across each load, so we can find V1 is just going to be I1R1. So 2.2 amps times 15 ohms. So V1 is 33 volts. Doing these in my head, hoping I'm not screwing up. V2 is just I2R2. So 2.2 amps times 24 ohms, 52.8 volts. V3 is I3R3, so 2.2 amps times 36 ohms, 79.2. V3 79.2 volts. Okay, so part A, we found all the voltages, the potential difference. Part B wants the equivalent resistance for the 3 resistors. In series, R total is just equal to R1 plus R2 plus R3. So 15 ohms plus 24 ohms plus 36 ohms. Our total should equal 75 ohms. And then part C wants to know the potential difference of the battery. You can find it 2 ways. You could say V total is equal to I total R total. So 2.2 amps times that 75 ohms you just found, which would be V total would be 165 volts. The other way would be to say, oh, V total in series is equal to V1 plus V2 plus V3. So add these up, 80, 165. You gotta like it when it all works out. 165 volts. Okay, so that's number 27. Number 28 only has 2 loads. One is 25 ohms, and the other is 35 ohms. Connected in series, potential difference across the 25 volt one, so V1, is 65 volts. 25 ohm one is 65 volts. Find the potential difference across the second guy for part A and the potential difference of the battery. So first you can find the I. So we know that I1 is equal to V1 over R1. V equals IR, right? So 65 volts divided by 25 ohms will give you an I1 of 2.6 amps, which will also be I2 and I total. So now we can find V2 because it's going to be equal to I2 R2. So 2.6 amps times 35 ohms. 70. I'm trying. 91, I think. 91 volts. That's what we're going with. And then what's the total potential? So V total should just equal V1 plus V2. So 65 volts plus 91 volts. So V total should equal 156 volts. And if you wanted to double check that, you could add these two together and get 60, and 60 times 2.6 would be 156, and it works. All right, number 29 says two loads in series are connected to a 75 volt battery, so my V total is 75 volts. One of the loads is known to have a resistance of 48 ohms. You measure the potential difference across the 48 ohm load and find it to be 40 volts. So V1 is 40 volts. Calculate the resistance of the second one. So you're looking for R2. So we can find V2, it's because in series the voltages add, so V2 is just equal to V total minus V1. 75 minus 40 should be 35 volts. Okay, so we have V2, and we can find I, because we know I1 will be equal to V1 over R1. So 40 volts over 48 ohms, 5 over 6 of an amp. And so now we can find R2, because R2 will just equal V2 divided by I2. So yes, I'm using V equals IR, and I am assuming you're going to be able to rearrange it correctly. So 35 volts over 5 over 6 amps, flip it and multiply 42. R2 is equal to 42 ohms, which I believe is the only thing that question actually asked for. All right, number 30. I drew my pictures before we started, so it'd be quicker. Two resistors in series, potential difference across. The first one is 56 volts, so V1 is 56 volts. The current measured in R2 is 7 amps, so I2 equals 7 amps. R2 is known to be 24. Of course, I wrote it up there thinking they were going to give me a voltage. 24 ohms. Find the resistance. Okay, so first, if I2 is 7 amps, so are I1 and I total. Okay, and so we have I and R for number 2, so we can find V2 is equal to I2 R2. So we can do 7 amps times 24 ohms, 168, I believe. 168 volts for V2. And we have I2 and I1 and V1, so we can find R1. R1 equals V1 over I1. So 56 volts over 7 amps. R1 is equal to 8 ohms. I should probably look and see what the question asked. Resistance, so this is A, number 1. Potential difference of the battery, so now V total is just equal to V1 plus V2. So V total is equal to 56 volts plus 158. Oh, sorry, 168 volts. So V total 224 volts. You could have also found it by doing V total equals I total R total. Okay, and then it would have been your 8 plus 20, 32 times 7, and you should get 224. And the equivalent resistance of the circuit, add them up. R total is equal to 8 ohms plus 24 ohms, 32 ohms. All right, last one in series, a 240 volt power supply, so V total 240 volts, is connected to 3 loads in series. The current of the circuit is measured to be 1.5 amps, so I total 1.5 amps, but that's also I1, I2, and I3. We're going to run out of time here. The resistance of the first load is 4